Thanks for coming out bright and early. I hope everyone had fun last night. Free beer and roller coasters. What could go wrong? At least the rain held off. So this morning we're going to talk a little bit about Azure Storage and about the tools and capabilities that are part of Azure Storage that help you keep it secure, keep it compliant with with the various industry regulations, and in general, put you in a position to use Azure for your most sensitive data, your most sensitive workloads. So we're going to talk through sort of a grab bag of different capabilities, and it's going to be pretty full. So we'll try to take questions at the end, and we'll hang around as long as we need to get your questions answered. We're going to let's just set ourselves, just make sure everybody knows we're talking about the same thing. Azure Storage is the foundational service in Azure that stores data for everybody. And we have a couple of different offerings that, that customers use. One of those is the virtual machine disks that you use. So these can be standard class disks, magnetic media kind of performance class. They can also be premium disks, and they also include the new Ultra SSD disks that were announced this week. So this is really, services itself is what looks like a disk in your virtual machines. But we also expose what we call an object store. So this is a REST service that's designed for applications built to work against data in the cloud. So this is essentially an infinitely scalable storage service that lets you store data, store it securely, store lots of it and manage it, be able to manage it economically. So we have different tiers, different price levels, different performance levels. And it's a great foundation for applications, for unstructured data. And then we also have a couple of services that are more sort of on the classic infrastructure kind of front. Those include Azure Files, which is a traditional Windows file share in the cloud, an SMB file share. And we also have a partnership with NetApp, Azure NetApp Files, which we're getting ready to launch, which will be essentially a NetApp filer as a service in the cloud offering NFS shares. So in addition to these online services, we also provide data transport capabilities through Azure Data Box, so that if you have a large amounts of data that you need to move into the cloud, and copying it over the internet would not really work because it would take too long, then we can send you one of these boxes and you can fill it up on your local network and send it back to us, and we'll load it into Azure for you. And then we provide several capabilities focused on these hybrid scenarios that help you bridge between your on-premise and the cloud. So these include services like Store Simple, which is a local NAS device that is backed up into the cloud. Azure File Sync, which is a way to extend your local Windows shares and Windows file shares and have them be backed up into the cloud and synchronized across locations. And then Avere, which is a really specialized high-performance cache, useful especially in media scenarios, that can really bridge the network distance between your on-premise and the cloud. So today, most of the things we're going to talk about are in the object storage and somewhat in the file storage space, the services that we'll focus on today. So just to ground us in how we operate, I know one of the most fundamental things about can I trust my data in the cloud is, well, how do they do things? How do they operate? So I want to just give you a sense for the sort of scale we operate at. Azure runs in more than 50 data centers globally. And anywhere there's Azure Storage. It's one of the services we got to use to essentially boot up Azure. And so it's everywhere. Part of being in all these locations is that there's lots of different local requirements. And so Azure has the deepest compliance offerings in the industry. And so these include sort of standard global offerings like ISO and SOC. But they also include local industry and government certifications. And so there's a long list of these. One of the things about certifications is that they do audits periodically, maybe annually or every couple of years. But when you have this many certifications, what it means is we're always under audit. At any time, there's multiple audits happening in Azure. So what that means is we don't get a break. We're always having to be disciplined and making sure our processes are always keeping us compliant. And what this means, the only way to pull this off is we automate everything. So we do a lot of things about the automation. We're very disciplined about our processes and training our people, and And so we operate in a way that's very hard for most companies to afford and most companies to be able to pull off. So I hope that helps you get a sense for, just in general, how we operate the service, that we can provide some level of trust. All right, so first we're going to dive into high availability and disaster recovery. I'm going to invite Lavanya to come up. I forgot to introduce my co-speakers, I'm sorry, but Lavanya is a colleague of mine in the storage team, and then we'll also have Ron from Microsoft will come up later, and Brendan from McAfee will come up. All right, thanks, Lavanya.
Thank you, Chris. Can everyone hear me? Okay, perfect. So I'm here to actually talk about the investments we're making from storage, Azure Storage, into the spaces of high availability and disaster recovery, and I'll also be talking about what's new in encryption at rest. So to kind of give a recap on what our replications options are for our storage accounts, predominantly, these are there to protect you against disasters, so basically to give you high availability and durability. So to kind of run down on the different options of replication we do have is the cheapest, most basic replication option is called the locally redundant storage. This essentially means that we are having 3 copies or 3 replicas of your data, which is locally in the region of where you've actually created your storage account. This helps protect you against node, rack, and those kind of failures. This does not give you disaster recovery kind of failures, so protection against disasters, but at least it kind of gives you protection against transient hardware failures and so on. The ACK basically, so we basically do 3 copies, and once all 3 replicas are committed, only then is the ACK sent to the user. The next level of replication option, which is slightly more expensive, but it protects you against regional disasters, is the geo-redundant storage. Typically, your geo-regions are around greater than 300 miles apart. The replicas now are 6, so 3 locally, and the other 3 copies are actually in your geo-region. So essentially, now you can see that because you have 6 copies, 3 on each side, you are basically protected against disasters. Remember that the replication from one geo-region to another is asynchronous, it's not synchronous. Now, the capability of users to basically query the secondary endpoint, how far is my secondary endpoint from my primary endpoint, is provided by this property called last sync time. So you can actually query that property on your secondary endpoint and figure out like it's behind by so many minutes. Now, this capability is overlaid on the GRS capability, which gives you your third replication option, which is RA-GRS, RA standing for Read Access Geo-Redundant Storage. So that's what I have over here, where RPO delay to secondary can be queried. That is nothing but your last sync time that you can query. We also have a replication option that protects you against zone failures. This is GA today in about 8 regions, and as we speak, we are expanding that. We are moving to more regions. This predominantly allows you to protect against zone failures other than node and rack failures. The replication in ZRS is actually synchronous. So having learned or having a recap on the replication options, let's look at what happens in our clusters and when there's a failure. So this is your typical clusters. We're just using an example of, let's say, your primary cluster is US West and your secondary cluster is US East. Always remember, storage favors durability over availability. So if there is a failure and we are not able to access the primary endpoint, we first try to recover data. And only then, if we truly can't, we need to basically do a failover. That is when we basically say, okay, we're going to conduct a cluster level failover. And we basically swap the primary and the secondary. So the DNS basically switches. All your requests are redirected. And your primary now becomes US East and your secondary becomes US West. You started out with primary being US West. So the two things to remember here is, like I mentioned, storage favors durability. So we don't really, we favor durability over high availability. So that means as a customer, if your promise to your customers are high availability, you are dependent on us making that call of basically doing that failover. 2, if you have any sort of network failures or any other outages which is not transparent to storage, you're pretty much waiting for us to kind of bring it back up. So what we've done is we've taken our customers' feedback and we've now basically given this capability of failover at a storage account level. So you are in complete control, irrespective of any other storage accounts in that cluster, you're in complete control of actually performing a failover from basically your primary to your secondary. So let's say your storage account is inaccessible, your primary endpoint is inaccessible. At that storage account, you can now click, I want to do a failover. We swap you to the secondary side. So there are a couple of flavors of this failover when we think about when you would use this. There are multiple scenarios. So typically you have, what do I do when there is a disaster? There's a region-wide disaster. I need to go to my secondary right now. So we call that as an unplanned failover or a forced failover. Basically, you're forcing yourself to go to the secondary endpoint. Remember that with that, you would actually have potential data loss, simply because our geo-replication is asynchronous, so your secondary has not caught up to the time at which your primary is. So when you click that failover, you've lost that amount of data. However, your RTO, which is the time to basically go to the secondary and make that your primary endpoint, is pretty much fast. The second scenario where I would use a failover is more of a planned failover. Typically, you would use this for DR drills, for your compliance, and also an interesting kind of scenario, which is an impending disaster. You know a disaster is coming in. So you don't want to really have data loss, but you want to plan for that failover. So this is when you would try to use this sort of flavor to that failover, which essentially means there's no data loss, and then you basically swap between your secondary and primary. You can also do a failback, which is seamless. So that is actually a planned failover. I'll definitely talk about what is there in preview now and what's coming in. So that's the second kind of option. Of course, the third option is when the system itself recognizes that there is, unavailability in your primary region, it automatically, basically, without any customer intervention, it basically just does a failover. So somewhat like a seamless, a transparent failover on behalf of the customer. So these three are the flavors, and I'll drill down into what we have today in private preview, and then talk about a little bit of roadmap. So what we currently have in preview today is the unplanned or the forced failover, which essentially means that you're losing a little bit of data, but your RTO, the time that you take to switch over to your secondary, is almost immediate. So let's actually look at how it actually works. So you have your storage account, you have your primary and your secondary. This is available only for, of course, as you can imagine, geo-redundant storages, so basically GRS and RAGRS. So your geo-replication is going on. The user basically decides, I have unavailability issues on my primary endpoint. I want to now go ahead and trigger my failover. You basically recheck and confirm that the region, the secondary region, is where you want to do, and what is my RPO. So RPO is basically indicating the amount of data loss that you're potentially going to have. You confirm that. So we invalidate basically the queue and the playback queue and the primary. So whatever data that you had written till that point, by querying your last sync time, that data is gone. And we invalidate that queue. So essentially, there's a DNS switch. Your account, when it goes into your secondary endpoint, now your current primary endpoint, becomes an LRS storage account, which means that we don't have 3 additional copies in your geo region. We wait for the user to basically convert that account to a GRS account, before which we start replicating into your new secondary or your original primary region. So right now we're looking at an RTO of 1 hour, and we also expose the queryable last sync time to essentially let you know how much of data you're going to lose. And of course, once you have gone into the LRS mode on your new primary, you can read and write data how you used to before. Of course, we're making future improvements. We definitely want to improve that RTO. And of course, we want to move over to a transparent failover. So next topic is encryption at rest. So as most of you know, the promise of encryption at rest is essentially to protect you against physical breaches. We've now enabled storage service encryption by default. It's always on. So essentially, whatever data you're writing into the storage account is getting encrypted. And this, all the data for all services, blobs, files, tables, and queues, everything is getting encrypted. We also have a background encryption process that will go retroactively and encrypt existing data, which is part of storage as well. The other is we offer an option for you to choose. So by default, the keys are managed by Microsoft, but we also have an option for you to bring in your key into Key Vault. There are many advantages of basically bringing your key into Key Vault. You can manage and better manage and control your keys. You can get audit logs for your key rotations, which most customers want as part of their compliance requirements. And also, of course, you get you can revoke access at any point of time. Also remember that it's at an account level, so you enable it, or it's already enabled at a storage account level. There is an account encryption key which is specific to each and every account, and we basically have a hierarchy of keys. The data encryption key is one such key that is derived from the account encryption key, and that's the key that basically goes ahead and encrypts your data. All unique writes that you write into your storage account are basically encrypted uniquely with this data encryption key. This is a screenshot of the portal today where you can choose your own key, or if you don't choose anything, by default it is encrypted using Microsoft Managed Keys. What's new in this space? So a lot of our customers, our ISV customers, they have multi-tenant scenarios where they have many customers, and now today with the way encryption is laid out, they need to create specific storage accounts for every specific customer if they want to segregate their customer data. An easier solution is, let's say we offer some sort of an encryption scope which is more granular, maybe more at a container level or even at a blob level. So what we've gone ahead and done is we've defined encryption scopes which are coming down at any level that you choose. So you can basically define that scope. Now, think of it as now the scope can basically be encrypted using a key that we manage, very similar to what we're doing today with our account encryption key. So either we manage that key and we rotate those keys, or we basically allow you to bring in a key into Key Vault, and that is the key which protects your encryption scope. You can also optionally kind of have a default setting for your encryption scope, which is at a container level. You can also go further down into the container level, and you can basically say for every blob write or read that you're putting into storage, you can define an encryption scope for that as well. The next investment that we are making is sort of a combination of client side and server side, where you are now basically in control of that key. So you're completely independent and decoupled from the storage or the Azure key management system. You manage it completely on your side, but the encryption is basically done by the server side. So you're saving yourself on CPU and those cycles. So you basically pass in the key that you want us to use for encrypting your data. We take that. We basically derive, again, a data encryption key from the key that you provide in your requests, and we basically encrypt it and store it. We never store the key. So for every read and write, you have to be passing in the key on those requests. The last investment that we are also making is automatic key detection. So today, our customer managed keys, when you bring in a key into Key Vault, today the behavior is after you bring in, you need to send a patch request or an update call to SRP or to our resource provider saying, this is the new key that I have got, so start using this new key. So basically, automatic rollover from your keys are not really detected by storage. Storage needs to basically get that request from you. So we are looking into how we can improve that, where you basically change the key in Key Vault, we automatically detect it, and we start encrypting data with the key that you've brought in. All right, thank you very much, and I'll hand it over back to Chris.
Okay. Thank you, Lavanya. All right, so let's talk about access control. This is a fun topic, close to my heart, partly because we're not very great today, and we're going to get a lot better. So let's talk about storage, oh, went the wrong way. Let's talk about access control in storage today. So there's a few challenges with what we have today. Today we have this thing called a storage account key, which is essentially an all-powerful secret that if you have this secret, you can do anything to any of the data in the storage account. So this is nice and simple. It was built in a time when people thought of storage as just purely a back-end trusted system, that your applications would take all the requests from users, and behind the scenes, they would know how to talk to storage. But people's patterns and usage of storage have changed from that, so it's not an ideal model. So we also have this idea of generating a token that has a limited lifetime, a limited set of permissions. This is called a shared access signature token, or SAS token. But in order to really use those effectively, you still have to build a service that decides which users have which permissions, and you got to generate the tokens for them and give them to them. You have to do this work of mapping user identities to the appropriate permissions. When those users, either with keys or with SAS tokens, read and write to storage, you don't know who the user is. There's no concept of identity in the storage system, and so there's no identity in those logs. It just says somebody who had permission did this transaction. So this is obviously less than ideal. What we hear from customers is they'd really like to be able to use their enterprise identities. They have all this investment they've made in Active Directory, as well as integration with Azure Active Directory, and all their other cloud infrastructure is based on those identities. They'd like to use those for storage. They'd like to take advantage of the unique capabilities of Azure Active Directory, like multi-factor authentication or conditional access policies, or the list goes on. Lots and lots of really powerful capabilities there that help you manage it more securely. And they'd also like to use that simple Azure role-based access control system to assign permissions. They don't like having their storage have to have sort of a different way to model permissions. That's yet another thing to learn. So what we've done is introduce identity-based access control to Azure Blob Storage based on Azure Active Directory. So this allows you to essentially grant permissions directly to users or to service principals, applications, using the RBAC system. And those systems can authenticate to you with a token they get from Azure Active Directory. So all of the work around managing secrets, managing passwords, now is all just part of Azure Active Directory, and you just bring us a token that says who you are, and then we use the Azure RBAC system to decide what you're allowed to do. So you grant roles, role assignments through RBAC to particular users at particular scopes, and those define what you're allowed to do. So this also lets you leverage additional things like privileged identity management, which says my users by default have a pretty limited set of privileges, but when it's time to do an operation that's sensitive, they can request to escalate their permissions and get a just-in-time access for a limited period of time to do a sensitive operation, and then that permission can go away again. So it leaves a much more secure sort of standard way of operating and administrating your service. So this is in preview now. It has been for several months. I hope you guys have had a chance to play with it. It's available for the Blob service and the Q service, our REST API services. And we're getting ready to take this to GA in the next couple of months before the end of the year. So let's take a look at how this works. So what you see here is a storage account. And if we drill into the storage account, let's take a look at the users in the storage account. So I'm logged in as a user who is an owner of the storage account. So you can see that I'm assigned here to the owner role. So the owner role has sort of permissions to do anything in terms of managing that storage account, including permissions to read those storage account keys we talked about before. So from that, he has sort of complete access to the data. Now we have another user in the storage account that just has read permissions. This is just a more standard user account. They have the reader role. What that means is that they can read the properties on the storage account, but they can't get the key, and that means today they can't get to the data. So if we go look at what that user can see in the portal of the data, they don't have access to the data. Now if we go back to the owner user and look at their permissions, you'll see that they, when you go browse the data from them, when they use the portal to get to the data, the portal knows that they have permission to list the keys, and so they get a copy of the key and they access the data using the key. So what we've done is change the portal so that by default it will try to connect now with your Azure AD permissions, and if that's missing, it will fall back to the key. And so that's why you see this purple message that says, hey, I noticed you're still connecting using that key. Maybe you should try using the role-based access control permission instead. So let's see how you would do that, how you would give those permissions. So let's go give that user account that we saw before who had no permissions to data, let's go give him permissions to data using RBAC. So the way we do that is we add a role assignment. So first we pick the role. In this case, there's a new set of roles that actually have permission to the data. So the existing roles like reader and contributor and owner, they don't have permissions to the data directly through RBAC, and they're not going to inherit them. So those roles aren't going to change and suddenly have access. But if we apply a role that's these new storage data reader roles, and then go back and refresh and try to access the data, now we'll be able to use that user's identity and check the permissions and get access directly to the data. So this is new in the portal. If you've tried this before in the portal, you may have been confused because you would give the right permissions and you still couldn't get access. But now we've updated the portal to take advantage of this RBAC capability. All right, so this is what it looks like in the portal. What does it look like in PowerShell? So in PowerShell today, the first thing you do is you log on. So you can see initially I haven't signed in yet. We'll show the subscription. It says, hey, you need to sign in first. So we'll just do that in a standard way. We'll use the connect Azure RM command, and we'll say sign me into this particular subscription when you're done. When you do this sign-in process in PowerShell, we pop up a little browser window. That's the way you sign in. And the reason we do this is that this is really our bridge to do all different kinds of authentication. So here I'm just going to use a username and password, but if I had multi-factor authentication configured, you would see that here. It could pop into use my workstation login and use certificates, or an app on my phone and make me enter a one-time code. So all those things come from Azure Active Directory, and they're enabled by this sign-in pop-up. So now I'm signed in as this user into the storage account. So into Azure. So the way the storage account PowerShell commands work is you create this thing called a storage context, which in the past was a storage account and a key typically, or maybe a SAS token. So we've added a new command to this storage account context command that says instead of using my storage account key, now I'll use this parameter that just says use the connected account. And what that essentially is saying is, hey, I just logged in. Go ahead and access storage using that connected account. And now when we issue a command to storage, in this case I'll enter a command to download a blob, for instance. I'll use all the same parameters before, where I put in the storage account name, the container name, and the blob I'd like to download. And then I'm just going to reference that context, which now is connecting using Azure Active Directory identity. And so everything else works the same. You just add this, when you originally create the context, to use this use connected account experience. So we'll run this command using our identity, and we'll be able to access the blob. All right, so that's PowerShell and user identity. So let's talk about your application identity. So there's some real challenges of trying to build applications that use all this rich Azure Active Directory stuff in the past. So one of those problems is that creating service principals, these kind of application accounts in Azure Active Directory, meant you had to have very powerful access. You had to essentially be almost a domain admin, a tenant admin in Azure Active Directory. And most companies don't give their developers this permission. So you end up with this friction and this process where developers have to go ask somebody very powerful, can you create a service principal for me? And it can be really hard for people to do it, and so they typically avoid it. But then if you really want to do this in production and do this securely, it's actually really hard. So now if I need credentials for this service principal. That means I either have to generate a strong password or generate a certificate that I use as credentials, and that process can be kind of hard and can be hard to do securely. And who's doing it? So whoever's generating that process, now do they have access to that secret? And how do I know they didn't take a copy of that secret and put it somewhere? So if there's a problem with that person. Once I generate these credentials, I got to put them somewhere safe because all my applications are going to depend on it. So I got to make sure I make a backup of them. But now how do I keep my backup secure? How do I make sure that the protection around my secret backup is safe and that people can't get in there and steal all my secrets? So how do I build that system? It's complicated. Now I have these secrets I need to deploy in my application servers. How do I deploy them in a secure way that doesn't involve some person in the middle, again, having access to the keys? Do I just have to trust a bunch of people and hope they don't steal the secrets? It's not a great situation. And also, once I deploy them to these servers, how do I store them on those servers in a way that they're safe, that somebody can't just get on the box and steal the secrets? And now that I've generated them, I have these compliance policies that I need to rotate them regularly in case they got disclosed. So I got to find a way to rotate them. I'm going to build all these processes that take me through this whole process again. So it's a little bit like rocket science. It's very hard to do this actually in a secure way where you don't have a bunch of individuals you just have to trust and hope they don't keep the secret and do something dangerous with it. So this is why we've introduced this concept called managed identities. The idea here is that we can do all that hard work for you, and you just take advantage of an identity that's associated with your resource, whether that's a virtual machine or a function app. And you can just say, hey, this virtual machine or this function app, they have permission to the data. And you can also create an abstract identity, just an identity that says, my application, and then you can associate that identity with your Azure resources, like your virtual machines or scale sets. So the way this works is, behind the scenes, when you generate these identities, we do all the work of generating and distributing and storing and rotating these keys. And you just, in your code, just say, I'm running in this Azure resource, in this virtual machine. I'd like a token now to talk to this service. And the managed identity service then will go and find the secrets it needs and go talk to Azure Active Directory and get the tokens for you and give them back. So this is in preview today. It's released for several platforms. Essentially, all the places you will run code in Azure soon will support managed identities, and we can completely get out of the business of managing secrets as application developers. So it's a very powerful service. Let's take a look at how this works. So we're back to the portal here. Now you can see I've got a list of a couple of virtual machines here. Let's drill into the second one. And if we look into this virtual machine, you'll see that there's a new tab halfway down called Identity. So this is essentially how you enable a managed identity for your resource. So in this case, a virtual machine, I just turn it on. You can see also, that's the System Assigned tab. I also have a User Assigned tab if I want to associate a pre-existing ID. And now that I've got an identity provisioned in Azure Active Directory, I can just go back to storage and assign permissions to that identity just like I would to a user or a group. So you can see here, if I look at the resource types, I've assigned this Storage-Blob data reader to this virtual machine. And that's really simple, similar to what we did before. We just pick a role, but now instead of searching for users, we can search for a virtual machine or search for a function app, find them, and give them permissions. So now you can see that I've granted permission to read data to this particular virtual machine. So now let's go to that virtual machine and see what the experience looks like from that side. So I'll do this a couple of ways. I'll start with what it looks like actually in the CLI experience. This is a Linux VM, so I'm going to use the Azure CLI. You can see, so I'm in an empty directory. I'll go download a file from storage as an example. So to start with, you can see that I'm not signed in yet to Azure, and it says you need to run AZ login. But this time, we're not going to log in as a user. We're going to say AZ login -- identity. That means use the managed identity of this virtual machine. So now we're signed into Azure as the virtual machine. And so I can run this AZ command to Storage-Blob download, and I can say download from this particular account and from download this particular container in this file. And now there's a new parameter at the end here that says which auth type I want. So by default, in the past, it would use keys or SAS tokens. But now we pass a parameter that says auth type equals login. You can see that here. And that says use the identity that we signed into Azure with to access storage. And so this login mode you can also set in an environment variable and have a default, so you don't have to even pass this with each call. So now you can see that I was able to download this blob, this file.txt, and you can see here's the contents of that file. So that's what it looks like from a CLI perspective. Both PowerShell and CLI are integrated with the new MSI, so when you want to run scripts on these virtual machines or inside of functions, you can just use those identities. So let's take a look at what it looks like to use this from code. So here's an example of a Java application running on this same virtual machine. So let's take a look at that. We'll go over to that folder, and we will show the Java source code. There's just a couple of interesting things in this code. So let's go back to the top here. You can see that at the top, we're going to get that MSI token, and then we're going to pass it to the storage APIs to go and retrieve a blob and display it. So the interesting work is in that MSI token. If we scroll down to this get MSI token function, you can see what we showed on that slide, which is essentially we're making a request to a local endpoint. This is the infrastructure in Azure. It's called the Instance Metadata Service. And we're saying, hey, infrastructure, give me a token to talk to, in this case, Azure Storage. But what's missing here is there's no secrets. I didn't have to pass any secrets or any certificates. I just asked for a token, and it knows I'm running on the machine, and I'm entitled to act as this machine, and it just gets a token for me. And then I just pass that token to the constructor in the storage API for a cloud block blob, and I download the blob, and it's that simple. So let's run this code, and we'll just show what it looks like. So we run it. We call Azure Active Directory and ask for a token, and we get back the token, and then we download the blob. So this is where it's most powerful, is when you're building your applications. I didn't have to do anything here with reading a certificate from the certificate store or reading a password or a secret out of config, and then making sure that whoever put that there did it in a secure way. All that is no longer my problem. So it really leads to a great situation, a much more secure situation for application developers. All right. So let's talk about Azure Files. So this is an area where people have been asking forever for, hey, why do I have to use a storage account key to talk to a file share? That seems really weird, and there's only one for my whole company. That seems really insecure. So this has really made it hard for people to adopt Azure Files in the past. We designed Azure Files initially to be a compatible file share, mostly for application scenarios, but customers really want to be able to use their user identities against their shares. So what we've announced is a preview of using Azure Active Directory and Azure Active Directory domain services to enable user identity access to Azure Files. And we've also, as part of this, essentially created NTFS permission models on the data itself. So we've really upgraded this from a really basic Windows 95 kind of a share to a real first-class file share with SMB and NTFS. And we'll also allow you to grant those share level permissions using RBAC. So this is in preview now. Give it a try and check it out. Today, initially in this preview, this is only on the SMB protocol for Azure Files. If you're connecting over the REST API, you'll still have to use storage account keys for now, but we'll be adding support similar to what we just showed for blobs in the future to files as well. Okay, so that's access control. Oops, sorry, wrong one. For identities. Let's talk a little bit about network access control. This is an important aspect, especially for people who would like to operate inside of virtual networks. And especially as we talked about before, the current situation where these all-powerful secrets for storage accounts, people are really concerned with, I don't want people to be able to access my storage account from the internet. I'd like to just take that storage account and only allow certain networks to access it. And so we introduced last year this idea of a storage firewall, which lets you control which networks have access to your storage account. And so today there's two different ways to do this. One is to grant access to specific virtual networks. So if you take those virtual networks and you enable something called the service endpoints for storage, that virtual network will then transmit securely the identity of the virtual network, even though it's on a private network address space. It'll transmit that identity of the virtual network to storage, and then we can enforce these firewall rules based on virtual networks and subnets. And then you can also use a traditional IP firewall rule for clients coming from outside on the internet, or from your on-premise gateways. So if you're using ExpressRoute with public peering, you can add the address of the ExpressRoute public peering gateway here and essentially enable only access from my on-premise networks, for example. So we're building on top of this some additional work in the network team so that instead of protecting who can come into my storage account, you can protect who can go out of, or where you can go when you go out of my virtual network. So one of the primary concerns people have with their data is that somebody can't take that data and send it out of their control to some other network. And in the past, it's been difficult with these shared multi-tenant services like storage, where if you allowed access to the storage service at all, that meant you were allowing access to lots of different storage accounts. And so the traditional network NSG rules wouldn't really close that gap for you. You either had to allow the whole storage service or don't allow the storage service. So what network service endpoint policies allow is that you can say, allow the storage service, but only allow these specific storage accounts from this virtual network. And what this allows you to do is to lock down only the storage accounts you trust that are under your control and prevent those data exfiltration scenarios that people have a lot of concern with. So this is available in preview today. There's a session earlier in the week that goes into detail on this, so I encourage you to check out that session and learn more about service endpoint policies. Some of the other feedback we hear from customers is that they'd really rather not go over public networks at all when they talk to Azure Storage. And today, when you're coming from on-premise, you have to go across the public peering path to get to Azure Storage. And some companies don't even want a public peering path. They don't turn that on. They just have access to those virtual private networks as extensions of their on-premise network. And so in the future, we're going to work on the ability for you to take a storage account and essentially project it into a virtual network so that you can route your traffic to storage only through that virtual network. And that IP address in your virtual network will essentially serve as a gateway to send your traffic then securely onto Azure Storage. So you don't have to deal with routing across public networks, and you can keep that locked down. So look for that coming up in the future. All right. So let's talk a little bit about monitoring. This is really important to maintain what's happening, to be aware of what's happening in your storage account, both from what are the transactions and what's happening in terms of accessing my data, but also how is my storage account being configured, and how am I aware of what those settings are, and are they complying with what I need them to stay secure. So today in Azure, the way you do this was with Azure Monitor. So Azure Monitor allows you to collect and visualize and analyze and take action on telemetry from all across Azure through one common service. And Azure Storage now publishes their transaction metric data and capacity metric data through Azure Monitor. And then we also provide a rich set of storage diagnostic logs today. Today, those logs just sit inside of your storage account, but in the future, we're also going to take those Azure Storage diagnostic logs and push them through Azure Monitor as well. So one scenario where Azure Monitor and monitoring in general can be valuable, here's an example of using the transaction logs. How many people remember, this has happened a couple of times, news stories about somebody accidentally took their cloud data and made it anonymous access, and then suddenly everybody's downloading. Yeah, so this is like the nightmare scenario for people now. So here's an example of, hey, how do I make sure nobody's accessing my data anonymously? I know nobody's supposed to. So in this case, you can say, show me the count of transactions where the way they're authenticating is anonymous and successful transactions. And so you can see here, let me zoom in a little bit. You can see here that we're drawing a chart here where the authentication type is anonymous. And then you can see that there was a spike of anonymous traffic here recently, and that's probably a little bit of a concern. So instead of having to sit at this graph all day and wait for something to happen, you can do alerts in Azure Monitor. So you can say, hey, build an alert that watches these transaction metrics, and as soon as I get a moment where the anonymous transactions are more than 0, send me an alert, file a ticket, something like that, and I can take action. So this is a great way to sort of proactively monitor, and there's a bunch of different things you could check here. When we have RBAC-based access, maybe you'd like to say nobody should be using the key, and you could say, let me know if anyone's doing any transactions using the key. This can also be helpful when you're trying to make a transition and you want to know, hey, have I managed to move all my applications off of using keys to using Azure AD identity? And you can see is there still any traffic coming along that uses keys. So it's an example of using monitoring. So having all this data in monitoring is very powerful, but how do you know what to watch for? It can be hard. And even if you're watching, how do you know what's normal for your particular application's workloads versus what's abnormal. And so this is where Azure Security Center comes in. I'm going to ask Ron to come up and share some of the great work we're doing in Security Center to help keep your storage accounts secure.
One, two. Do you hear me? Okay, good morning. My name is Ron Machora. I'm a product manager as part of Azure Security Center product team. Azure Security Center is a service in Azure that allows you to understand and maintain your security health of your Azure resources from a central place. I'm glad to share with you some new security intelligence capabilities that we are offering in Azure Security Center that allow you to improve the security state of your storage account. Once a year, Verizon publishes a report that analyzes over 50,000 security events and data breaches that are reported by organizations in the previous year. Every year, they report new attack vectors, new cyber methods that are used to breach organization. But if you look at the last few years, you can see some repeated patterns. First of all, you can see that no organization is immune for data breaches. These reports include large organizations, small organizations from different segments, financial, government, education. Second, which is even more interesting, most of the data breaches that were reported involve sensitive data that's with financial value, which means credit cards, personal information, customer information, employees information. And third, over 30% of the data breaches that were reported by organizations involve malicious actors, which means a partner or an employee that have access to the data stores. Since a lot of the sensitive data is being stored in storage account security requires special attention. Most organizations are struggling, having limited access, knowledge, tools, and methods to secure their data. They are struggling to identify security misconfiguration in the storage account and fix it. They are struggling to detect suspicious access to the storage account if someone is extracting sensitive data from the storage account. And the good news is Azure Security Center, together with the Azure Storage Service, allows you new capabilities that allow you to address those concerns. So first, I would like to announce and share with you today that we provide new security recommendation for storage account in preview, which allow you to identify storage account misconfiguration. It provides you a set of action items, recommended actions, that allow you to fix those as you go. I will demo it in a second. Currently, it includes few recommendations. We are improving it as we go. So it allows you to check your storage account is not using allowing non-secure transfer, which means HTTP and not HTTPS. It allows you to identify that you have storage account which didn't limit the network access. Again, especially if you have sensitive data in the storage account, it's recommended to use the features that Chris just mentioned to limit network access to your storage account. And last, it's identified that you are using the old version of the storage account, and it's recommended to use the new Azure ARM resource storage account, which provide better security, better auditing, better Arbor control. And second, and even more powerful than that, so I'm glad to announce that we offer today advanced threat protection for storage accounts. These features allow you to detect unusual and potential harmful attempts to access or exploit your storage account. Very simple to enable. I will show it in a second. Just turn it on. Once you do that, automatically, as advanced threat protection learns and profiles your activities on your storage accounts and detect unusual access. So for example, if you have someone is accessing your storage account from a different location, which you didn't use before, someone is accessing from anonymous access, which you didn't use before, or if someone is extracting your data. While improving these features as we go, more and more algorithm, and once the service identifies there is a suspicious access, it will trigger an alert, an email alert, with all the information, and you also be able to view all these alerts from a central place from Azure Security Center. This is the list of alerts that we currently offer. So we have a set of access anomaly alerts. We have a set of data extraction and deletion alerts. And we have a set of anomalous activities. Again, all of this, we are improving it. We are adding more and more. Based on our knowledge, we are running millions of storage accounts, millions of different data stores. So we have a lot of knowledge to provide you the best automatic threat detection you can get. So let's dive into a demo. Sec. Security. Okay. So the first thing I want to show you, again, another security. Okay, the third thing I want to show you is the Azure Security Center recommendation. So Azure Security Center, as I mentioned, it's a central service. So you can go to Security Center from the main menu, and you can go to Data and Store. And over this overview, you can see the list of different data stores, including a storage account, and provide you a recommendation where something is misconfigured. So as you can see that it's identify there are around 129 storage accounts which are allowing HTTP and not HTTPS. And again, you can drill down to this list, and it provides you the list of storage accounts that have these capabilities. And it even takes you to the storage account to the right place, which allow you to basically fix it and enable a security required access. Other one, again, it's identify the network accounts that are not limited to restricted networks. And again, you can get the full list. And the last one is it's identify if you are using a storage account, which is the classic storage account, which is not the newest and the more secure storage account. This is the security recommendation. Now I want to show you the advanced threat protection. Again, in that case, you need to go to the storage account blade. And in the storage account blade, you have a new entry that's called advanced threat protection. Again, one click, and you will be able to enable that. So I'm going here. You can see advanced threat protection. Again, one click, and that's it. You are protected. And once there is an issue, automatically the service will send you an alert. So let's say an example of this alert. You can see that you get an alert over email. All the storage account admin will get this email. So someone is extracting your storage account from unusual location. It provides me the IP, the location itself. It provides me clear investigation and remediation steps. And I can also see it from a central place, from Azure Security Center. So again, you saw the Azure Security Center recommendation area, but there is another area for the threat protection for all the alerts. So you can see here all the alerts. You can click on that, and you can see that the different alert that was triggered on the storage account. Let's take now a different alert, data exfiltration. So now I'm getting into the details, and I can see again the storage account. I can see the storage type, the container name. And again, it seems that someone has extracted an unusual amount of data. Again, we do it based on machine learning and artificial intelligence. We learn your behavior for this specific storage account. And after a while, when we see there is a normal activities, so we are triggering potential data exfiltration in that case. And again, clear remediation and investigation steps. And as I said, we are enriching it as we go. You will get more and more of this good stuff later on this year. Okay?
Okay, thank you, Ron. Okay, so now you've got your telemetry and your monitoring, and you can see the data about your storage accounts, and now you're getting some guidance about what are the things you should really correct and watch out for, and here's some things to be concerned about. But if you're trying to do this at scale, you really need to be able to use something like policy to say, hey, here's the policy for my environment. Why don't we make sure that everybody is following these guidelines? And so that's where Azure Policy comes in. So the idea of Azure Policy is that you can define rules, you can define policies that say the kinds of settings you want for your enterprise, and then you can both report and enforce that those policies are applied across your enterprise. You can enforce these things at low scopes, like say just my resource group, I have a specific set of policies, or you can say my whole subscription, or even across multiple subscriptions, using the new feature management groups, where we can say all the subscription in my enterprise need to comply by this particular policy. You can also get recommendations to enforce and add these policies from Azure Security Center, as Ron just showed. So here's an example of a policy, and you can see that we give statistics about, for this particular policy, how compliant am I across the scope that it's applied to. And then also you can set these policies, and if someone tries to make changes to for instance, a storage account that doesn't comply with these policies, maybe the HTTPS only setting we saw before, you can actually set it to block those changes or block creation of new accounts that don't comply. So once you get clean, you can stay clean. So some interesting uses of policies for Azure Storage include requiring that the firewall is on and that you're using encrypted protocols over the wire. You can enforce that we're using one of those highly available or disaster recovery configurations, so I make sure my data is ready for in case of a disaster. You can say I only want my data in particular regions to meet your particular compliance obligations. And in the future, we want to add additional ones, like just being able to block using anonymous access at all. How do we prevent somebody from using that? Or block using old TLS versions that are not necessarily particularly secure. So we're constantly looking for new things that we can add to the palette for Azure Policy. So this is an area we'd love your feedback on. Let us know what you'd like to enforce across your storage accounts. Okay, so we talked a lot about the infrastructure and about monitoring. Let's talk about the actual data. How do I protect my data itself from somebody, accidentally or maliciously changing my data, deleting my data? So we've got a couple of things that help in that space. The first is a feature called Soft Delete. Soft Delete is really intended to help with those sort of accidental oops moments where somebody hit delete and they need to go back. How do I get that data back? I didn't mean to. And so Soft Delete essentially lets you set a retention policy, and any deletes or changes to your data, we keep a copy of the previous data in a soft deleted state for some period of time that you configure. So in this case, we're showing 7 days. It could be up to a year, for instance. And once we do that, any changes that anyone makes, you can reach back to them, restore from one of the old versions, and make it live again. So if it's deleted, you can bring it back to life. If it's an older version, you can make it the current version again. So this is sort of the early version. And where we're going next with this is just the overall idea of object versioning, where every time anybody makes a change to any object, we just keep the old one as an older version, and we keep the full version history of the objects. So that's coming in the future. The other piece that's really helpful for protecting your data is just to make a rule that says nobody can change it at all, even if they have permissions. So we do this with something called immutability policies. These are especially helpful in cases where you have a compliance obligation. This is very common in the financial services industry, where you have to retain a set of data and prove that no one could have changed or modified it for a long period of time, maybe 7 years. It's also very helpful in those cases where you have ongoing legal matters and you need to make sure you're preserving documents, and so you need to essentially place a legal hold on your data. So we provide two different models here for these policies. One of them is a time-based retention, and this says that for whatever the configured period of time is for this container, make sure any data that's put into that container is not changeable and not deletable until that time period expires. And then for a legal hold, you essentially add as many tags as you want of specific legal holds, maybe a case number, to any particular piece of data or container. And when you do that, all that data is essentially immutable until you remove the hold. So, on the time-based policies, the thing to be careful of is that once you create a policy, there's one more step to lock it. And the reason we did that is because you could sort of accidentally or just trying out these retention policies, but once you lock it, we don't let you turn it off because that's the whole point. You can't turn it off. So be careful about locking a policy because you'll have data there you won't be able to delete for however long you set it, and that could be years. So there is an unlock, so you can try them before you lock them, and they're still enforced, and you can see how they work. So give them a try. So this is interesting as well when you combine it with the new lifecycle policy work we're doing, where you can have scheduled automated operations on your data. So one common pattern we see is that I'd like to configure a time-based policy that keeps this particular data for at least 7 years because that's my legal requirement. But as soon as that time period is up, I'd like to delete it immediately. So you can combine it with the automated lifecycle policies and the immutability policies to really get the behavior you want. Okay, so now you've protected your data, you've kept them from deleting data you don't want to delete. But one nightmare for people is that they use this storage as sort of a Dropbox for people to put bad content, right? So what if somebody's uploading viruses to my storage accounts? How do I protect against that? And so we've got several different partners in this space who are doing work to allow you to do essentially traditional virus scanning, but in a cloud scale against Azure-Blob storage. And so I'm happy to have Brendan from McAfee here. He's going to come up and talk about some work that McAfee's doing to really enable this virus scanning and content scanning in Azure Storage. So welcome, Brendan.
How do we switch to me? Am I on?
Yeah, you're on.
Okay, great. Thank you. So hi, my name is Brendan Kelly. I'm with McAfee Security. You will probably hear me use the phrase or the name Sky High during the presentation. That was the company that McAfee acquired, so I don't do it to confuse you. I just do it because we've only been part of McAfee for about 6 months now. So I'm going to talk about advanced threat defense for Azure Storage. I've got a couple of demonstrations I'm going to show around 2 use cases, but before we do that, I want to talk a bit about architecture and the use cases themselves. So you've got Azure Storage with blobs configured in the upper left-hand side. McAfee Sky High Security Cloud is delivered as a cloud service. So what's nice about this is, unlike some traditional security products you're thinking of, you don't have to install anything on premise. We're delivered as a cloud service. You don't install anything in Azure. Everything is cloud to cloud. Within the cloud, we actually have a DLP engine, and that cloud DLP engine can run the advanced threat defense policies that we're going to see here. End user experience is the same. They upload content to Azure, upload, download, everything happens normally for the end user. But then we can do alerts both to the end user and to administrators. So the cloud can actually alert end users when they violate a policy or can send alerts out to your SOC. So the first one we're going to talk about is examining content at rest. So this would be an example where I've just turned on the security policies. I've got data in my blob storage. I need to look at that. So I want to look at any legacy data I have, or over time as I add or change policies, I want to be able to go back and sort of retroactively look at the data that's stored out in all of my blobs. So that's the first use case we're going to look at here. And in this one, I can figure out how to turn on my video. Oh, there we go. So I've logged into my Azure account. I've logged into blob storage. I've got a single blob I'm going to look at here, and nothing's configured yet. So I'm looking at this. I've got 3 files here, a couple of EXEs, a doc file, all relatively standard and innocuous. The fact that it's CEO resignation, I think, is a little bit unusual, but we've got these files, and this is what we're going to end up scanning. So what we're going to do is we're actually going to set up the service, the Sky High service, the McAfee Cloud Security Service, via an API. So again, machine to machine, cloud to cloud. We're going to enable the API. We're going to go in. We're going to check for some prerequisites. We're going to make sure that they're there. And then we're going to authenticate. And when we authenticate, the authentication actually happens in the Azure cloud. So you as an administrator would actually log in, and you'll see it's the Azure authentication. You grant us access, the ability to look at that storage to determine what's in there. You give us that permission, but we don't then have those credentials. So they're still securely held within Azure. It's not something that we as McAfee have. It's done. I've got my green check mark. That tells me that everything's OK. Now I'm going to look at my policy. So I'm going to go to my DLP policy. I've got one pre-configured here. You'll see one for McAfee Advanced Threat Detection. When I look at the policy, this is actually going to look at behaviors and some of the aspects of the file. So this is really sort of traditional anti-malware. We can also look at content. So in this case, we're going to look at a couple of very specific file types. We're going to look for advanced threat detection, and then we're going to generate what's called an incident based on that. Now we're going to go set up the scan. So we're going to say, what part of our blob storage do we want to look at? So again, we've got one configured here already for the ADT. We're going to look at that. We'll edit it. It's got a couple of different components on it. Basically, you're determining what policy am I running, and I can run multiple policies. You're determining what services I'm running, because we can do this for blob storage, but we could do this for something like OneDrive or SharePoint as well. And then I'm determining, here's the policy that I've got put in there. And then I'm going to determine when am I going to do this? Am I going to look at everything? I can do a full scan, or I could do an incremental scan. I can go back X period in time, and then I can determine which blobs I'm going to look at. I can do sort of everything, or I can do them against specific buckets or specific blobs that I'm concerned about, specific containers I want to look at. So here I've got my account. Next, now I'm going to decide, am I going to schedule this, or am I going to run it on demand? And in the demonstration, we're going to do it on demand, but we can also set it up to be scheduled to run daily or weekly on a regular basis. So for this one, it's going to be on demand. We're going to save this, and then we'll go ahead and we're going to kick this off. So we'll press play. It's going to run, and through the magic of a recorded demonstration, we're going to get a couple of incidents almost immediately. We're going to click on the incidents. You'll see this here. There are 3 of them. Surprisingly enough, we had 3 files. We've got 3 policy violations. These are the policy violations against that policy we had set up. We're going to drill into one of these. And now what we can do is look at the details. So it tells us a lot about what the file was, the storage, the account that was associated with it. But now we can actually look at the details. And this is the advanced threat detection. So this tells us what matched in there. So this is all of those attributes and behaviors within the file that determine it to be advanced threat detection. So that is us using the API to look at data at rest. And again, you saw the setup. It was almost in real time, so it sets up really quickly. So the next use case is scanning content in real time. So now that I've got this set up, I've gone back, I've looked retroactively at what I've got or what's happened in the past. Now I want to look at what happens for everything going forward. So here, again, my video is going to start. I'm logged into the same storage container. I'm in my blob. I'm going to upload a file here that I know is going to violate policy. So I've got a couple of files. I'm going to open them. I'm going to upload them. I don't have to do anything here to change the policy. I don't have to set up a scan or anything like that. Once I've turned that policy on, as long as it's active and assigned to this service, it's going to run. And you'll see I uploaded those files, almost immediately got a new incident. And again, drilling into the details, we're going to see those attributes and behaviors that caused it to violate policy. So what's nice here is that once I've defined that policy and enabled it, I don't have to do anything about setting up a scan or a schedule or anything like that. From that moment forward, we're going to look at all the new data that's uploaded. So that way you're getting continuous protection automatically by turning on that policy and assigning it to the service. So both content at rest and content in motion or data that's being uploaded can be scanned. And what's important is we can do this for blob storage right now, but we're having conversations in development, doing development against some of the other so non-blob storage. One of the big ones that we're going to go after initially is going to be Azure Files. It's a conversation that's very far along between the 2 teams because we understand it's becoming something that's very important to customers like yourselves. Thank you.
All right, thank you, Brendan. All right, so we'll wrap it up. What did we cover today? So we talked about how to keep your data highly available using the replication options and some of the new customer-controlled failover at an account level to put you in control. One of the really great things about that is now you get to decide this calculus between availability and durability. And for some customers, we have to always keep the data. The data is the most important thing. But for other customers, the ability to maybe take new orders is the most important thing. And I'm willing to give up a little bit of data to make sure I'm back online. So putting you in control of that decision is really important. We talked about how to protect your data from physical breach using encryption at rest and some of the new additional controls we're adding there to give you more granular control of different encryption scopes. We talked about how do we use identity-based and network-based access control to make sure that only those who should have access to your data do have access to your data, and how we make that much simpler using Azure Identity, Azure Active Directory identities, and also managed identities for Azure resources. We looked at monitoring, how do you use all this telemetry and the data that's available to make sure you're using your system in a safe and compliant way. We talked about how do you enforce and monitor that compliance using Azure Policy. We talked about how you can protect and preserve your data from accidental or malicious delete, and also how you can prove to, in your industry, that you're meeting your compliance obligations relative to that using immutability policies and legal holds. And then finally, we talked about how can you scan the content itself and protect yourself from malware and viruses. So that's the end of our question. I really appreciate your feedback about this session. If you can fill out the evaluations and let us know what was valuable to you, what else you'd like to learn about Azure Storage. And then we got a couple of minutes for questions. We're happy to take questions, or we can stay up afterwards and answer your questions there. So thank you.